Tomorrow you have your properties of exponents quiz. So what I wanted to do is create a little something that would help you move at your own pace and make sure you're comfortable with all the different property rules, because there's a lot of them. So we're going to take it and we're going to look at each one individually and make sure you're comfortable. Feel free to rewind this, replay it, work the examples with me as many times as you want. The goal is for you to feel comfortable when it comes time to take your quiz tomorrow. So there's a couple things I want you to find within your notebook that will be very helpful. The first one is this warm-up we did the other day. If you remember, you wrote all of these down, and all it is are these are the rules, and they're the rules individually. And I think individually you can do this, no problem. It's when we put it together that's when it gets a little tricky for you. So find this and make sure you understand what the rules are. Another good resource for you is this worksheet that I gave you. You had the foldable, and then right next to it should be this. This, again, goes over each property, and it also has examples, so that's really, really, really helpful. So when you're ready, I'm going to go ahead, I'm going to go through each one of these properties and work out a couple examples with you. Here's our first rule, the product of like bases. So this is basically saying if I have a base, remember the base is the thing that repeats. It can be a letter, it can be a number. It's the thing that has the exponent. If the bases are the same, I can add the exponents. So we're going to work through these examples to make sure you understand. Now please bear with me as I'm on the iPad and my handwriting looks disgusting on it, but we'll make it work. So here we start off, we have 3 squared, and you guys told me before that 3 squared simply means 3 times 3. You were very comfortable with that. And 3 to the 4th power meant 3 times 3 times 3 times 3. So if I asked you to then write this back with exponents, you would have a base of 3 because that's what's repeating, and an exponent of 6 because there's 6 of them. So if you apply your rule up here, your shortcut is to simply take your exponents and to add them. And you know that 2 plus 4 is 6, so therefore it works. So what I want you to do is I want you to take a second, pause this video, and try the next one on your own. And then when you're ready, click play and we'll go through it again together. All right, so your next one I'm going to do is I'm going to take a second, I'm going to expand them out. So x to the 5th power is x, there's 5 of them, so you would write out 5. And then there's going to be 4 more, so 1, 2, 3, 4. Now the base is whatever's repeating, so in this case it's an x, so I would write x, and then I would count them up. And as you count them, you should see that there are 9 of them. So that should have been the answer you got. Remember, if we take our shortcut and we apply our rule, we would add 5 plus 4, and we would get 9. So there it is. That's your product of like bases. You take the base, you keep it, and you add the exponents. The second rule we have is the quotient. Remember, quotient means that you divide. So the rule says that we take them, again, they have the same base, and we subtract the exponents. So there's 2 examples I want to work out again. The first one, we're going to do the same thing we did before. We're going to write 5 times 5, because that's what 5 squared means, over, and then there's 5 more on the bottom. So once you have that, we know that if there's the same thing on the top and the bottom, they could cancel out because 5 divided by 5 is 1, so it goes away. So that goes away and that goes away. That leaves me with 3 5s, and as you notice, they're on the bottom. So I would have 5 to the 3rd power on the bottom. We have to have something on the top, and so we're always going to put a 1 there. This is kind of an easy segue into our negative rule, so we'll go ahead and do that. According to this rule, I can subtract my exponents. So 2 minus 5, there we go. That looks horrible, but it's okay. So 2 minus 5, if you apply your integer rules, I'd sing the song, but I don't want to right now. I'm sure you can start singing it. 2 minus 5 would be negative 3, and 5 to the negative 3rd power becomes the fraction. You can't have a negative exponent, so that's how you get this answer right here. You can technically take this one step further by figuring out what 5 to the 3rd power is, which would be 5 times 5 times 5. So your final answer would be 1 over 125. If you got to this part tomorrow, I would be very happy, and I know you know what you are doing, so that's great. So here's your next example, the x's. Go ahead and pause the video again, try it for a minute, and then when you're ready, we'll go through it. Okay, x to the 8th power. We have 8 of them. I don't know if I have enough room for 8 of them, but we'll try. 4, 5, 6, 7, 8. That looks horrible. That's okay. And then 6 more on the bottom. 1, 2, 3, 4, 5, 6. And then, just as before, we will cross out the ones that we can. So 1, 2, 3, 4, I think there's one more over here, 5, and 6. That leaves 2 of them, and they're on the top. So that would be x squared. And again, applying our rule, we would do 8 minus 6, which is 2. So you would get x squared. So now we get to power of a power, and this was throwing us off a little bit. So power of a power says that you have a number in the parentheses, and then it's going to repeat however many times you see on the outside. So x squared to the third power means that there's 3 of them. So it'd be x squared, and x squared. If I were to write it all out, I would write x, 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 x. But because we just reviewed that rule, we know that 2 plus 2 plus 2 is 6. So it's x to the 6th power. Again, the shortcut on this one is that I can take my 2 and my 3 and I can multiply them. That's what this rule right here means. You can multiply them. So 2 times 3 is 6. Try the next one on your own, and then when you're ready, let me know. Okay, so 5 to the third, 4 times. 1, 2, 3, 4. So my base is 5, and I add them. 3 plus 3 plus 3 plus 3 is 12. And again, the shortcut, 3 times 4 is 12. Moving on to this one, the product to a power. This is where we really started to get confused because we didn't know what we wanted to do here. We didn't know if we should add, if we should multiply, so here we go. This first one, if you'll notice, there's 3 different things in the parentheses. So if I wrote it out, I would have 3 u to the third, v to the fourth, and then 3 u to the third, v to the fourth. So I would have a 3 here and a 3 here. Well, 3 and 3, now these are both multiplied together, so you just multiply them. And 3 times 3 is 9. And then you have u to the third again, so using our rule, we add them, u to the 6th. V to the fourth, you add them and get v to the 8th. If you apply your rule, you would give this squared right here to everything that's on the inside. So you would have 3 squared, I'll write it down here, 3 squared, and then, ooh, that doesn't say it, 3 squared u to the 6, because you multiply them, and v to the 8th. I apologize for that ugly 3 squared right there. And as you know, 3 squared is 9, so you have 9 u to the 6th, v to the 8th. So try the next one, and then come back when you're ready. Okay, using your rule, you would multiply them, so it's a to the 8th, b to the 12th. If you want to write out 4 sets and then add them, please feel free to do that. If that helps you, do it every single time. Okay, so now we have the quotient. This is the same idea. You have to give that exponent to each part. So I would have 3 cubed over 7 cubed. If you could take it one step further and actually work it out, 3 times 3 times 3, that would be great. 7 times 7 times 7, that would be great. But if you stopped here, at least I know you know what you're doing. So go ahead and try the next one. And when you're ready, let me know. All right, so we give the squared to everything. 2 squared x squared over 3 squared y to the fourth. Now, how did I get the y to the fourth? Because I did 2 times 2. So then I work it out. 2 squared is 4. The x squared stays. 3 squared is 9. Y to the fourth. That's my answer. All right, my favorite one, the 0 exponent. I love this because it doesn't matter how nasty the thing is inside the parentheses. If the whole thing is set to a 0, your whole big ol' answer is going to be a 1. So the next one you should be able to do, even if I take a breath, you should be able to answer it. So, okay, answer is 1. Good. Anything to the 0 power is 1. And then our last rule is this negative exponent, which we already touched on. Anything to the negative power is going to be a fraction. And we talked about why in class. We talked about how when we did the 4 to the second, 4 to the first, 4 to the 0, 4 to the negative 1, 4 to the negative 2, we talked about what happens. So anything to the 0 power drops below, it drops downstairs, and it becomes positive. So 1 over x to the 6. So this one would be 1 over 3 squared. It looks like an 11, but it's supposed to be a 1. And you know that 3 squared is 9. So it should be 1/9. Okay, we have a couple more minutes left on this video, so I'm going to take this time to put it all together because, again, in their own, you do fine, but once we put it together, that's when we get a little bit confused. So here we have a problem. And if you look at it, take it piece by piece. So the first thing I would focus on is this 5 over 20. If I just gave you 5 over 20, you would think of it as a fraction and you would simplify it. I can divide both by 5, so it becomes 1 over 4. Then I have my x's. I have x cubed over x squared. So using our rule, we would subtract it. If you want to write it out, x, x here, and then 2 here, you could cross these out and you're left with 1x. So you just write an x. If you just apply your rule, you would do 3 minus 2 and get your 1. And then you do the same thing with the y's. There's 9 on the top, there's 2 on the bottom, so 2 would cancel out. That gets you y to the 7. That's a 7. Okay, let's try another one. These are a little blurry, but it still gets the point across. So again, the first thing I look at is the fraction, the 2/3. And I ask myself, can I simplify 2/3 at all? And the answer would be no, so I can't do that. So then I stretch it out. Then I look at the b. There's one b by itself, so it's going to stay there. Now I have the a's. Our rule here is to subtract -3 minus 2. Same sign, add and keep, gets me -5. And as you know, we can't have a negative on the top. So we would take this and move it to the bottom. Makes our answer 2 over 3. The b stays where it is, and the a, we said was unhappy because it's negative, it drops to the bottom. All right, here's our next one. So go ahead and pause it again. Why don't you try this one on your own? All right, so I'm assuming you're ready. So we're going to look at just the regular numbers first, and I see a 5. It's still there. It doesn't have anything to cancel out with, so it's going to stay where it is. Then I have some y's next. I have y. Remember, this is technically to the first there. So my rule is to do 1 minus -4. And you know with your integer rules that this becomes a plus positive. So 1 plus 4 is 5. So that's y to the 5th power. Positive stays on the top. Then I have my x's. I would subtract again. So 3 minus -3 becomes plus positive again. So it becomes 6. X to the 6th. Everything ends up moving upstairs. And we talked the other day that if you don't like negatives, move them beforehand. So if you know that these are both negatives, they're both going to go upstairs. So it would be 5y x cubed, that stays. And then the other x cubed comes up, and then y to the 4th. Then you're just adding them. And then here's our last one. So take a second and try it, and then we'll come back and do it. All right, you multiply your coefficients, your 4 and your 3, which gives you 12. And then you have your exponents, so x, and our rule is to add them. And they would be 9 plus 5, which is 14. If you wanted to write it out, you could write 4 with 5 x's behind it, 3 with 9 x's behind it. You would add the x's and you'd get the 14, and you'd multiply the 4 times the 3. So that was my quick review, about 15 minutes. Feel free to look back over this as many times as you want. I think you'll be very successful if you take your time and focus tomorrow, and I will see you then.